Uh, okay, so guys, we'll now move on to the next part of the lesson. So we move, this is actually the most important part. Okay, so the most important part is where you use tables to find probabilities of the standard normal distribution Z. Okay, so you guys now have some kind of an idea about the normal distribution, right? So let's recall quickly what you know. So what is it? Number one, the normal distribution is a symmetric distribution, right? So it's symmetric around the mean. It's symmetric around its mean, and you know the total area. The area under the graph represents the probability. So if the area under the graph represents probabilities, the total area is 1. Okay, total area is 1, and which means, so since this graph is symmetric, okay, so normal distribution number 1, it is symmetric. Symmetric means, in other words, if you recall from your previous chapter, do you recall something about skewness? So if a graph is, I mean, if the distribution is symmetric, then you know the skewness is 0, right? Zero skewness. Okay, there is no skewness. Okay, there's, we can say like this, no skew. Okay, so these are some important things. So normal distribution is a symmetric distribution, basically no skew. And then number two, the area represents the probability. Okay, so area equals to probability, which means total area is equal to 1. Right, the total area under the graph is equal to 1. And since this is symmetric, guys, you should know, because it's symmetric, it's going to be exactly, mu is exactly in the middle. So either side, you have the area half half. Because obviously if the total area is 1 and if this is the middle, then each side has half, the probability is half for each side. All right, guys. So these are some very important things. Okay, so then so this is just I mean, we were working with normal distribution in the previous exercise as well, but now this is the most important one, because we learn about a very special type of normal distribution, and that is called the standard normal distribution. Okay, so this is the most important one. Okay, so they say here tables are provided in the textbook and the exam to help you calculate probabilities for the standard normal distribution. Okay, the standard normal variable is usually denoted by capital Z and has a mean of 0 and a standard deviation of 1. Okay, so this is very important. Okay, so in the standard normal distribution, okay, in the standard normal distribution, your mean is 0. Standard normal is denoted by capital Z. Okay, the mean is 0. Can you see? And the standard deviation, guys, it's gonna be 1. Okay, so the shape of the graph, if you consider, it's the only difference is now that the mean value is 0. So basically, behind the mean value, you have negative, is that you have negative x values here, and here you have positive. So mean is directly 0 here. Okay, so that's the main thing here. Okay, and then, okay, so the common way of writing this is that follows a normal distribution. So you write it like this. Okay, these are just notations, so you don't have to worry about it. Okay, Z follows a normal distribution with mean 0 and variance 1 square. Right, guys, I think previously, did I show you that if Z follows a normal distribution, this is how we normally write, right? Mu and the variance. Like this is the way we normally write the distribution parameters. Okay. So in this case, we have replaced the value. Our mu value is 0 and our variance. You guys know sigma square is variance, right? Sigma is standard deviation, the square of that. Sigma square is variance. So so in this case, because our sigma is 1, so here we write here sigma square. You could just leave it as 1 if you want. Okay, 1 square is 1. So anyway, so this is the way we denote it. So the moment you see this, you know this is a standard normal distribution. Okay, so basically this table is constructed around mean 0. Can you see here? This table is constructed around mean 0 and variance 1. Okay. Okay, so now we'll move on to the most important part. So, guys, you, as I told you, tables are provided to you in your textbook, and also you can refer to the it's behind, right, the end of the textbook. You will find tables for the normal distribution. Also, you will find this table in your IAL formula book as well. Okay, so I hope you have one of these materials in your hand, because I'm going to teach you now how to refer to this table, and how to calculate probability. Okay, so first we'll learn how to refer to this table and calculate probability. Okay. All right, guys. So now let's move on to the most important part, right? So how to read the table. Okay, so here, guys, I'm going to go with these standard notations. Okay, so we'll go with these standard notations. So this one. Okay, so the first thing that I want you to get used to is this notation phi A. Okay, so this we say here phi A is often used as a shorthand for writing that the probability capital A. Now, guys, you know here capital A or these capital letters denote random variable. Okay, so the random variable is lower than a certain value simply. Okay, so guys, if you look at this, okay, just first we'll get used to the notation, then we'll start using the table. Okay, so when you have this, when you have your normal distribution, okay, here the mean is 0 now. Okay, we are working with the standard normal distribution. So you can see here, this is 0, right? And you can see here how they've named the graph, right? So you can see here values, positive values on the scale and negative values go behind, right? So these are your z values, okay? So let's say you have some value here, okay? So let's say there is some value here, okay? So that's what they've named here as A, okay, guys? So then the area behind this particular line, okay? So the area behind it. Okay, so we define this as this is the probability that your variable capital Z is lower than A. You could even use less than or equal. Actually, you guys know now we are working with continuous distributions, right? So previous chapters we worked with discrete, but now we are working with continuous. Now you know in continuous distribution, guys, whether it's equal or less than or equal is not going to make an impact. Okay, it's not going to make an impact. But you know, in discrete distribution, it makes a big difference, right? The less than mark being here and not being here makes a big impact because if they tell you that x is less than 2, then you know you don't take 2, right? So in distribution, in discrete distribution, the next value behind 2 is 1. So x less than 2 is x is less than or equal 1, right? In discrete distribution, right? So if you recall those tables that we did with discrete distributions, so I think we did many examples here, right? So that is for discrete though. However, in continuous, guys, you know that if you say x is less than a certain value, it doesn't actually matter whether the equal mark is there or not. This is continuous. So which means you know that even if you say z is less than 2, guys, you know that even 1.9, 1.9999, all these values are still included because it's continuous. Okay, because all the values are included. It's not just including those specific values. It doesn't only include the integer values, right? So it includes everyone. So is that less than 2? Basically, the probability of is that less than 2 and probability is that less than or equal to are exactly the same. It doesn't change. So this is one important property that you need to remember about continuous distributions. Okay, so this is something that you can only use in continuous. This will not work for discrete. Okay, so remember, if you want is it less than A or is it less than or equal A, it doesn't make an impact here. Okay, so that's one important thing. Okay, so they're both the same for continuous. Okay, so now I want to give you the notation. The first thing here is, guys, we say the shorthand notation. Okay, so probability is that less than A is also given by the notation phi A. So if you see this notation, whenever you see this notation phi A, it means, okay, so it means that it refers to this. So if I give you phi and 2, what does it mean? It means the probability is that is less than 2. Are you with me? So if I give you phi 1.5, it means the probability that z is less than 1.5. Let's draw the table, draw the distribution as well. If I draw the distribution here for phi 1.5, it means visually it means like this, right? So mean is 0. And you know 1.5 should be like somewhere over here, right? This is 1.5, right? Definitely it's in front of 0. So this is 1.5 and z less than 1.5 means we are referring to this set. This is the probability we are talking about. Can you see, guys? Okay, so a similar diagram can be drawn for this as well, right? So if I say uh, phi minus 0.5, what does it mean? 5 minus 0.5 means it's the probability that your variable, the standard normal variable, is lower than. Okay, so guys, that's important. The definition is that it's lower than. So it's lower than minus 0.5, this probability. So how do you find the, I mean, I still didn't teach you how to find the probabilities. I'm just giving you a visual idea. So here, this is the mean 0. Minus 0.5 is, a little bit behind, right? So it's over here. So minus, you can roughly mark, okay? This doesn't have to be accurate. So you just roughly mark. The minus 0.5 is behind the 0. And then, so Z is less than means you shade the area behind. Right, guys? Can you see? Okay, so this is the general idea. First thing I want you to have is this general idea. Okay, guys. So I think that is understood, right? This is just a notation. Okay, I still you just need to understand the notation. So this area is phi a. Okay, the area. Okay, so then guys, you know that the total area under the graph, right? The total area under the graph is 1. So if the total area under the graph is 1, okay, so guys, I think you understand this phi a represents probabilities, right? So when you give this phi notation, it gives you the probability of behind the, okay, the probability of the area or the probability behind a, right? So guys, what's the area on the other side? The area on the other side is what we refer to as 1 minus phi a, right? So why is it 1 minus phi a? Because if this area, okay, so this is very, very important that you understand. So if this area is phi a, okay, so if this area is phi a, right, and you know the total area is 1, the other end of this should be 1 minus phi a, right, guys? Do you get what I'm talking about? This is that's really important. So how do you denote this probability? So for example, guys, now you saw that phi a is the area behind, right? So when you say phi a, it means that z is less than a, right? So then, guys, I think you can see referring to the table, okay? Mean 0, this is the a. Okay, so phi a refers to the area behind. So what if I give you like this? What's the probability that z is greater than a? Can you see, guys? Z is greater than a means you now need to go to the other side, the other end. So I'm now coloring the right side. Okay, so if I want to go to the right side, okay, is that greater than a? So this is 1 minus the phi a because you know this area is phi a. Right, guys? So the total area is 1. So this end should be 1 minus phi a. So that's really important. Okay, guys? So this conversion is actually very important. Okay, so remember probability. So you can directly use this. Okay, so whenever we are doing some work, you can directly use this. Okay, so let me emphasize this again. Probability Z is greater than A is equal to 1 minus probability Z is less than A, right guys? That's what it means. Can you understand? So this is the probability Z is less than A. The one I'm shading here in blue. Right? Phi A means the probability that it's less than. Right? So the blue color area is the Z less than A area. So if you subtract the less than area from 1, 1 minus this area gives you the greater than area. Right guys, are you with me? Okay, guys, so I'll just give you a few more examples because I feel like you'll need a little bit help. Okay, because this annotation is important to understand. Okay, then it makes things very easy for us. So guys, again, as you can see, just to give you a hint here. So here the mean is 0. You can see the positive 1, 2, 3, 4 is x values are on the right side. Negative 1, negative 2, negative 3 are on the left hand side. Basically, it's like a not just a usual graph that you draw. Okay, so it's the axis is there. Okay, so just the notation. Okay, so if I want you to find the probability that Z is greater than, let's say I want you to find the probability Z is greater than, even the equal mark can be here. Okay, the equal mark doesn't make a difference, you know that. So let's say I want to find the probability Z is greater than 1. So how do I get the probability Z is greater than 1? You can first draw the graph. So this is how the graph looks, right? So mean is 0. So this is where you have 1, right? So 0, 1 should be on this side, right? So is it greater than 1 means, guys? You draw the line. You need to draw a vertical line at 1, and greater than or equal 1 means you shade this side. Right, guys? You shade this side. But the thing is, okay, so you need to be, the thing is, in your normal distribution tables, they always give you the area to the left hand side. The tables that you have give you the area on to the left hand side, the main table. So then what you can do here is you can write z greater than or equal 1, that area as 1 minus the probability z is less than 1. Are you with me? So this side, 1 is the total area. Remember here 1 means the total area under the graph. So from the total area 1, if you subtract the behind area, okay, if you subtract this behind area, right, is that less than 1, then you get the other side. Is it greater than or equal 1? So this guy is what we refer as 1 minus, this is called the phi 1, right? Because phi means the less than area. Are you with me, guys? Another example, let's say probability z is greater than or equal minus 2.3. So if it is greater than or equal minus 2.3, how does it work? You draw the graph. This is 0. So minus means, guys, it's behind 0, right? So you can mark minus 2.3. Just roughly mark it. Minus 2.3 over here. So this is what you have. Is it greater than minus 2.3 means, guys, you're supposed to shade the area in front of it. Because this is the greater than side, right? Is it greater than means to the right side. Are you with me? So z greater than minus 2.3 is also equal to what? Total area is 1 minus the probability z is less than minus 2.3. The probability z is less than minus 2.3 is this area, the green color area. So the z less than area as a notation is written as 1 minus phi minus 2.3. Are you with me, guys? Okay. Guys, here this negative sign doesn't come out. Okay, I still did not teach you how to find this value. Okay, so I'm yet to teach you how to use the table to get these values, right? So I still didn't teach you how to get that. Okay, so I'll be showing you very soon now. Okay, so I'm going to show, I'm just trying to show you that I mean how to use the notation, because it's important that you can handle this notation and it makes life easier for us. Okay, by the way, so here phi negative 2.3 is the area behind minus 2.3. So you need to understand that you get a positive figure for it, right? Because you are getting an area, okay, and this area is a positive answer. Okay, so phi minus 2.3 is not negative. Okay, so it's a positive, you get some kind of a 0 point figure for this area. All right, guys? Okay, so another important thing I want to emphasize here, okay, using the symmetry. Now you know the graph is symmetric, right? Okay, so this is our mean 0. So let me consider two values here. Let's say I have the value 2.5. So here negative 2.5 and positive 2.5. So if you take 2.5, negative 2.5 and positive 2.5, it's equal distance, right, from the mean. If it's equal distance from the mean, guys, what do you recall? Do you recall from the previous exercise? If you are at an equal distance from the mean, then you should remember that these areas are equal. Are you with me? Okay, so these are some important things to remember. Okay, so these two areas are exactly going to be the same. Are you with me? So these you need to remember these simple things in order to make your life easier when we use the tables. Okay, so the other important thing is, if you are, it doesn't have to be, it can be any value. Okay, I'll just write a here, negative a and positive a. So if you have negative a and positive a on either side of the mean, then you should understand that the areas they generate on the tail ends are exactly going to be equal. Okay, that's also one very important thing. Okay, so now actually let's move to reading the tables now. Okay, so let's see actually how to use the table now. All right, so we'll move on to exercise 7b, and let's actually practice finding the values for these questions. Okay, so you're supposed to use the normal distribution tables to find these probabilities. Okay, so let's get started, guys. So the first one, the probability that z is greater than 1.27. Okay, so let's get started. The probability that V is greater than 1.27. Okay, so I need to find the probability V is greater than 1.27. All right, guys. Okay, so first thing I advise you to do here is, okay, draw the graph. Okay, first thing is let's draw the normal distribution. So, this is how the normal distribution looks like. And the mean is 0. Okay, so where is 1.27? 1.27 is a positive figure. So just mark roughly. This is 1.27, right, guys? So you want the area Z is greater than. So Z is greater than means you need to shade the area to the right side. Greater than means you shade this. So this is the first thing you should draw. Okay, so your task, what's your task? Your task is to find this area. Okay, so your task is to find the shaded area. Okay, so now how do we find the shaded area? Okay, so to get the shaded area, guys, this is where we use the table. Okay, so you can find this table at the back of the book, or you can find in your formula book as well. Okay, so this is the table, and you guys can see they have defined the phi z function. Do you recall the phi z function? So we were defining our areas for phi z. So what is phi z? Phi z is the probability that your z is smaller than that particular simple z. Okay, so phi z means, in other words, okay, phi z gives you the area. Okay, phi z gives you the area. The mean is 0. I'll assume z is positive. So this is the simple z. Okay, so phi z gives you the area behind the line. That's also very important. Okay, so phi z gives you the area behind the line. Okay, guys. Right. Okay. So you can see here phi z. This is actually the proper calculation done for this. Okay. So this is how they have calculated all these values. So you really don't need to use this function. Okay. You don't need to input. You don't need to use this function because they have used this function and actually given you all the probabilities. That's how the table is calculated. Okay. So phi z is 1 over root 2 5, the integration of e to the power minus half t square dt. Okay. So you don't need to use this. Okay, so that's why they've given you the table to make your life easier. Okay, so let's look at the first value. Now look here, guys. So here the first z value is 0. Okay, let me first go with this. Okay, so the first z value is 0 and you can see the phi z value is 0.5. So what does that mean? So what does that mean here? So what it means here is this is the phi 0 value, right, guys? This is the phi 0 value. So what is phi 0? Phi 0 is that the probability z is less than 0, right, guys? Phi 0 means the probability z is less than 0. And you can see here, this is the mean value 0. So is it less than 0 means, guys, you can see that we are talking about this area, right? And you can understand, it makes sense that this area is actually 0.5, right? Can you guys understand? Right? Because, so basically in this table, for every z value, you can see they've given you positive z values. Okay, they've given you positive z values. Okay, so z values are what you have on the, okay, let me show you. Let me just go through a few more examples. Okay, so let's see. So over here, guys. Okay, so let's take another one. Here, let's go with 1. Here, z equal 1. Okay, let me go with this guy. So what does this mean? Okay, I highlighted the value in the table. So what does this mean? Okay, so here the z value is 1, the simple z value. Okay, the simple z value is what you mark on your x-axis. Okay, so if I draw this one, guys, look at this. So I'll draw this one. How do I show it? You know the mean is 0. So here the z value, simple z value is 1. So remember, simple z value is what you mark on the x-axis. So what do I mark on the x-axis here? I mark 1. Can you see I'm writing in green here? So this is 1. So here, this is, they have given you, this is phi 1, right? So guys, this 0.8413. Now here your simple z value is 1. So this what they've given you here is phi 1. Okay. So this value here is phi 1. So what does phi 1 mean? What does phi 1, what does it mean? What is its significance? It's the area behind the line 1, right? It is the area behind the line 1. And you can see that this area is how much? 0.8413. So this area here, guys, is 0.8413, the phi 1 area. The phi 1 area is equal to 0.8413. Can you see how the table, how the tables have been used? So it's very important. Let me do a few more. So let me shade this. Okay, let me shade another value. Okay, let's take this guy. Can you see the one I shaded just now? This one. Okay, so I'm talking about this. Okay, so here the simple z value is 1.54. Okay, so I'm still not solving any sum. I'm still showing you how to read the table. So if the simple z value is 1.54, what does it mean? Let's draw it. Okay, so the mean is 0. Always first mark the mean. Okay, mean is 0. So where is 1.54, guys? You know 1.54 is in front of 0. So this is 1.5. But just roughly mark. Okay, so then always the phi z value. Okay, so this is the value we are talking about now. Okay, so this is the phi 1.54. So phi 1.54, they have given us 0.9382. So you know phi 1.54 means what? It's the probability of behind the line, right? Of behind that line. The probability of the value behind the line. So this is the 1.54. So behind area. The behind area is phi 1.54. How much is the behind area? So this phi 1.54 is this area, which is 0.9382. Right, guys? Can you understand what I'm talking about here? So this is just explaining you how to read this table. Okay, it's just a simple explanation. Then we'll go to the sums. It's just another one. I'll take a value from here, this guy. So I'll take this value. So one last one. So what does this mean? So what this says here is, what this guy says here is, what they are trying to say here is, let me answer this, phi 2.3, 2.30, phi 2.30 is 0.9893. So what does phi 2.30 means? You know, phi 2.30 means Z is less than, the area that Z is less than 2.30 is 0.9383. This is what it means, right? And then you can show it on your graph. So the mean is 0. And then 2.3. You mark the 2.3 here. And then, you know, the phi means the area behind that line. So the area behind the line, you can mark the area behind the line. And this area, this behind area is the 0.9383. Or this behind area is the phi 2.3. Okay, guys? This behind area is phi 2.3. Okay, so now I think you guys have a good idea about like at least how to use the table, right? So I was just demonstrating you how to use the table, but we'll come back to our sum. So what was our sum? So we were discussing on this question. We were supposed to find the probability Z is greater than 1.27. So guys, one of the issues here is in this table, you can see they don't give you the greater than probabilities directly. This table is only giving you the phi z values, which means they give you the areas behind. Only the less than areas can directly be found. So if they want you to find any greater than areas, you will have to you do a little bit of calculations, okay? Because this table doesn't give you the greater than area. This table only gives you the less than area. Okay, so how do we work on this? Okay, so let's do this now. Okay. So let's work on this. So guys, how does this work? Now you know this table only gives you the behind area. It doesn't give you the forward area. But I have given you the formula on we described the method on how to get the greater than area, right? So do you recall? I gave you if the probability Z greater than A is equal to 1 minus the probability Z is less than A, less than or equal A. It doesn't matter if the equal mark is there or not, but This is the general formula, right, guys? So this is one of our main equations. So z greater than is equal to 1 minus the less than, right, guys? So I want to find the probability z is greater than 1.27, right? So this is equal to 1 minus the probability z is less than or equal to 1.27. Are you equal? Do you get what's going on here? So 1 minus, this is in other words, 1 minus 5, 1.27. This is what we want. So 1 minus, guys, what 5, 1.27? So we can go to the table now. Let's go to the table. 1.27. Where's 1.27? I think I'll have to move this. Yeah, right, guys. Can you see 1.27? Here, 1.27. The one I'm shading in yellow. Do you see? So 1.27. 5, 1.27 is 0.8980. Are you with me? So this area is 0.8980. This is the behind area. Right, guys? And then it's just a matter of calculating, right? So in the calculator, you type 1 minus 0.8980. And then what is the answer? So you get 0.1020. Is this correct? Yeah. All right, guys. So that's correct, right? So it's 0.1020. Visually, it's this area, the blue color area. That's this area. Can you see 0.102? Okay, the zero is not, I'm just writing the answers to 4DP because the table gives everything to 4DP. So basically 0.102. Okay, so this area, this blue area is 0.102 and this is our answer. This is what we are looking for. Okay, guys. Okay, and then let's go to the next one. So we want to get probability z is greater than minus 1.66. All right, so let's get that probability z is greater than minus 1.66. Okay. Okay, these are a little bit tricky now. How do we do this one? Probability z is greater than minus 1.66. Okay, so you'll have to use a little bit of tricks here. Okay, so what is the issue here now? The first problem is you can see as I told you before. Okay, as I told you before, one drawback of this table is, guys, you can see only the positive z values are there. Do you see that they don't go for the negative z values? So you don't find any of the negative values. Now you know the z values are distributed around 0. So on this side you have positive 1, 2, 3, and here you have negative 1, negative 2, negative 3, right? But the thing is, you can see this table, the z values, okay, they don't go for the negative side. Only the positive side is given. The negative sides are now here. You are supposed to work with a negative value, but negative values are not given. So when they do, how are you expected to find the probabilities? You're expected to find the probabilities by using the symmetry of the graph. Okay, because you know the graph is symmetric. Okay, so when you are trying to find the negative probabilities, okay, you're expected to use the symmetry of the graph. Okay, so let's see how we can do that. Okay, so there is 1.66. Okay. Okay. Let's first draw. First thing is let's have a visual idea of what's going on. So the visual idea here is this is 0. This is minus 1.66. So minus 1.66 is behind 0, right? Okay. And so here, what's the area you're supposed to find? You're supposed to find the area Z is greater than minus 1.66, right, guys? So you need to find this area. Okay, you're supposed to find this area. Are you with me? Okay, so here I'm going to show you a little bit of a shortcut. Now, the thing is, guys, you know you can't work with minus 1.66. We know that, right? Okay, because we don't have that in the table. But, guys, now you know you're trying to find an area here, right? So, do you see this? I'm going to draw another graph here. Okay. You see that these graphs, the areas, okay, the values, even though the values change, I'm going to draw another graph with the exact same area. Here, this is 0. Okay, you guys know now this is minus 1.66 was over here. So guys, if I go to the other side and go to positive 1.66, it's the exact same distance away from the mean, right? The exact same. I'm going to take the positive value. Okay, the positive value away from the mean. And guys, what do you think about this? I'm going to take this area. What do you think about these two areas? So here the problem, now you can see here, is that greater than minus 1.66? This is the area that I shaded. Okay, and I'm taking the exact same guy, the exact same value, but the positive one. So I'm using, but what I'm trying to do here is I'm trying to use the fact that the graph is symmetric. I'm using the fact that the graph is symmetric, and I'm getting the, you can see here, I'm getting the positive 1.66 on the other side, which is exactly the same distance away from the mean. And okay, that these two areas must definitely be equal, right? Then they need to be, they have to be equal, right? Because this graph is symmetric. So the same area you represent on this side, the area in front of minus 1.66 is the same area you have behind positive 1.66. Are you with me, guys? Okay, so I'll give you guys a rule here. All right, guys. So what's the answer? So you can now get the answer directly, right? So we'll go with this right now in this manner. So 1.66, Z value 1.66 is over here. Can you see? Here, I'm shading. Can you see? 1.66, the area behind is 0.9515. So guys, the answer, okay, so basically you can write like this, okay? So probability V is greater than minus 1.66 is also equal to the probability V is less than 1.66. So this is very important, this relationship. Okay, so probability Z greater than a certain value. You can use this. Okay, probability Z greater than minus A is equal to probability Z less than positive A. So this is a relationship that you can always directly use. So I suggest you to actually remember this. Okay, so directly use this, guys. So this is the main rule. Probability Z greater than a negative A value is equal to probability of Z less than the positive of that same A value. Directly use this, guys. It's going to make your life easier. Okay, it's going to make your life easier, and you memorize this as a certain rule. Okay, so you can directly use it in the exam. No proof is required. So what's the answer now to our question? So the answer to our question, probability V is less than 1.66. So you can see 0.9515. Okay. Probability V less than 1.66. That is 1.66, right? Directly. This is 0.9515. You can directly write the answer. This 1.66 is not necessary to be written. I'm just trying to get you used to the notation, okay? Because if that less than areas are 5, directly 5 values, right? If that less than areas are directly 5. Okay, so I just wanted to get used to this notation. Okay. Okay, let's go for the next one. All right, guys, so continuing with the rest of the question, probability Z is less than minus 2.28. First thing, draw a diagram. Okay, so one of the main challenges in these questions are dealing with negative values because your table doesn't have negative Z values. Okay, so first thing you mark the mean 0. And you mark minus 2.28. Okay, so what area are you supposed to find? It said it's lower than. That is lower than minus 2.28. So is it's lower than minus 2.28 is now this area. Okay. So the problem here is, guys, okay, the problem here is, so Z is lower than means directly this is the phi value, right? So this is directly phi minus 2.28. But the problem is we don't have phi minus 2.28 because your Z values start from 0. So you don't have a minus 2.28. So guys, what you do is now, okay, so I'll just give you let's draw another diagram. Okay, so whenever they give you a negative value, what you should do is consider the symmetric positive value. Consider the symmetric positive value. Here, this is the mean 0. So this is the negative 2.28, right here. So instead of working with the negative 2.28, take the exact same value but the positive value. Positive 2.28 because they are symmetric, because they are at the same distance from the mean 0, right? So they are exactly the same distance. So then, guys, the same area. Now you can see here you have shaded a very small area. That small area, you can get it by this area. Can you guys see? This small area here, you can see that the diagram makes sense, right? If I draw like this, so this small area here is equal to this small area here. Can you guys see? Okay, so I can give a general rule here to make things easier for y'all. Now you can see here, first of all, now you're trying to find the probability that V is smaller than minus 2.28, right? So this is equal to probability what? V is greater than plus 2.28. Are you with me? Do you see it makes sense? Now you're supposed to find the area that V is lower than minus 2.28. But according to this graph, you can see by the symmetry. You consider the symmetry, I drew this other graph. Okay, and I shaded the area by using intuition, right? You can see, right? I mean, it doesn't make sense to shade this side. It's much larger, right? So I have to shade the right hand side to make the, I mean, you can see then the areas are looking the same. So now you can see that if I want to get the, now my question is to find the probability Z is less than minus 2.28. So you can see that Z less than minus 2.28 is equal to probability Z greater than 2.28. Okay guys, so Z greater than 2.28, but you know this table doesn't give you greater than value. This table only gives you less than value. So then this is equal to 1 minus the probability Z is smaller than 2.28. Are you with me guys? Do you get it? Okay, because the greater than probability, I'll write it again with a different color pen. Because greater than is equal to 1 minus less than, right guys? Do you get it? Because I take the less than area and subtract it from 1 and I get the area I want. Do you get me? So I go to 2.28. So you have to go to 2.28. This is over here. I'm shading 2.28. You can see. So, so this is actually 1 minus 5, 2.28, right? Because the less than area is the 5 value directly. So 1 minus 5, 2.28 is 0 0.9887. So how much is the answer? 1 minus 0 0.9887. Is it 0 0.0113? Yeah. Okay, so in this case, I'll give you another general rule to make your life easier. So I gave you a general rule previously. I told you to remember that rule, right? This rule that I gave you previously. So likewise, the second rule I'll give you right now, and you can use it to make things easier, especially when we go to the 9C exercise, okay? So here, if you had to find the probability that Z is lower than negative A, okay? So I gave you previously the rule when if it is greater than. So if Z is less than negative A, this is equal to the probability Z is greater than positive A. Can you see guys? I think you can see the relationship, right? So can you see the way this goes now? So if you have Z greater than negative A, it's equal to Z less than positive A. You have to change the inequality and change the sign. I think that makes things very easy for you, right? You can see here, if Z is lower than minus A, then that is equal to probability Z is greater than positive A. So here, I flipped the inequality and I flipped the sign. So this is a really easy method for you to remember. Okay, guys? So Z less than minus A is equal to Z is greater than plus A. Okay, guys? So Z greater than plus A, we can just write a little bit more, right? Z greater than plus A is 1 minus probability Z is lower than A. So you can write this a little bit extra. Okay? But these are some very important rules that can help make your life a lot easier. Okay, so I recommend you using these. Okay, so I'm writing them here. I hope you can see them clearly, right? So make sure you make good use of these rules. You can directly use them. Okay, let's directly use them. Okay, let's go for the next one. Okay, so the equal mark, as you know, okay, being here, not being here makes no difference. Okay, let's go to the next one. So part D, Z is between 0 and 1.31. Okay, let's get started on this. Okay, so you have to find the probability. Z is greater than 0 and smaller than 1.31, right? Okay. Okay, now again, okay, so I'm going to again give you some rules, okay? So general rules to make your life easier. First, let's draw this and let's see how this visually looks. Okay, so now instead of working with one value, you have to work with two Z values. Okay, you have to find the area between two Z values. Okay, so here, this is 0, right? This is the mu value of 0. Right, guys, you can see this mean is always 0 and then there is a value 1.31. So let's mark 1.31 here. Okay, so in this case, you can see they want you to find the area is that between 0 and 1.31. Are you with me? So Z value is between 0 and 1.31. So this area. Can you see, guys? You have to find this area. So what's the easiest way of getting this area? So the easiest way of getting this area is, guys, you can see, you can get the full area behind 1.31, right? Get the full area behind 1.31, and what do you think you should do? After that, you get the area behind 0. Then when you subtract the area, the complete area behind 1.31, okay, so you get the full area behind 1.31. And then if you subtract the area behind 0, do you see that you are remaining with this part? Guys, do you get what I'm saying? So you take here, how do you work here? You take the area behind 1.31. This is the full area, the one I'm showing in green. This is the full green area. From that, you remove the probability that Z is smaller than 0. That is the pink area here. So when you remove that, you can see you are only remaining with the area you require. Do you see it, guys? So the Z less than means directly this is 5 1.31 minus Z less than means directly 5 0. So you can get the values from here, right, guys? So 5 1.31, 1.31. So okay, so you'll have to get we'll have to move the table down. 1.31 is 0.9049. Okay, so 0.9049. Okay, and then the other value is when Z0 is at the very front, right here. Z0 is the very first value. All right, here 0.5. Are you with me, guys? So 0.9049 minus 0.5 is 0.4049. Okay, so this is the answer. So let me give you again a general rule, okay, to make things easier for you guys. So rule number 3, okay, and these rules, guys, you can use them directly. So I suggest you to use them directly to make things easier for you all, okay. So the next rule, if you have to find the probability. All right, guys, so third rule, so where you have Z between A and B, okay, so where you have Z between A and B, obviously A should be smaller than B, okay. So this is found by directly, you take the 5B and subtract from 5A. Okay, guys, so this is the next rule. Makes your life very simple and easy. Okay, so use these. You can directly use them. Okay, there's no need for any proof. It's obvious. Okay, so you saw it now from my diagram, right? Why it's obvious. So from the 1 point here, Z, A and B values are 0 and 1.31 here. So you subtract the area behind 1.31. I mean, you take the area behind, completely behind 1.31 and subtract it from the area behind 0. Then you're remaining with the small, the portion of the area that you require. Okay, guys? Use these rules. Okay, make things easier for you all by using them. Okay, so next one, the next rule, the next question. Pretty much the same, right? Probability Z between 1.30 and 1.89. So let's do this. So probability Z between 1.30 and 1.89, right? Okay. So I think you guys know how to do this now, right? So what do you do here? There's nothing much to do. You take the phi 1.89 value and subtract from the phi 1.30 value. That's it. From phi 1.89, you subtract the phi 1.30. That's it. Just directly subtract, okay? So what do you get? Phi 1.89, you have to go down, right? Yeah, here phi 1.89 is over here. Do you see, guys? 1.89 here. 0.9706 minus phi 1.30 is over here, right? 1.30, 0.9032. All right, guys, so it's a matter of subtracting. Okay, so what's the answer? 0.0674. Is that correct? Okay, 0.0674. This is the answer. All right, guys. So this question. Okay, so this question, I can show you several approaches of doing this question. Okay, one by using the rules, one by using the diagram. Okay, so I'll show you all the methods. You can choose any that you wish. Okay, so there are many ways of doing this sum. Okay, multiple ways. The first thing is I'll maybe go with the diagram. Mean is 0. So what are our two values? Minus 2.8 and minus 1.6. Okay, so you're supposed to get this area, right? The area between minus 2.8 and plus 1.6. That's what you're required to find. But you know minus 2.8 minus 1.6 is not there on this table. It's not there. Okay, so what I can do here is, guys, I can make use of the symmetry. Okay, and I can mark the same guy plus 1.6 and the plus 2.8 and get the area in between. I think you can see that the blue area and pink area must be equal. It has to be equal because the graph is symmetric, right, guys? If the graph is symmetric, then I mean, since I have marked the same values, the positive and negative, they must be the same. These areas, the area between minus 2.8 to plus minus 1.6 must be the same as the area between plus 1.6 to plus 2.8. It has to be the same, right? Because the graph is symmetric. This is one way of doing. Okay, this is one way of doing. So this is equal to the probability V is between plus 1.6 to plus 2.8. Okay, so then this is equal to phi 2.8 minus phi 1.6 by using this rule that I gave. Okay, because here it's I gave the positive value. So here phi 2.8, you can get it from the table. 2.8, I think I can see it here, right? 2.8 here, 0.9974. Can you guys see? I shaded here. 0.9974 minus phi 1.6. Do you see 1.6? I think I'll have to shade it, bring it down. 1.6 at the top here, right? Can you see? So that's 1.6 here, 0.9452. Okay, so you subtract and you get your answer. That is 0.0522. All right, guys, this is one way, method one. Okay, So I'll show you method 2 as well. Method 2, I'll try to make use of these rules. Okay. So method 2, you need to get the probability z is between minus 2.8 and minus 1.6. Okay. Okay. Let's directly use the rule now. Okay. I'm going to go directly with rules. Let's see if that works. So this is actually equal to, you know how it works, right? So this is going to be 5 minus 1.6. You subtracted 5 minus 2.8, right? According to this rule. Okay, now I'm not drawing the graph. I'm trying to go directly. Okay, so this 5 minus 1.6 means, guys, you know this is z less than minus 1.6, right? 5 minus 2.8 means this is the probability z is less than minus 2.8. I'm going to use this rule, this table, this rule. So, you know, if you are dealing with negative z values, you can make them positive. How do you make it positive? By flipping the inequality and changing the sign. So, z less than minus 1.6 is the same as z greater than plus 1.6 using this rule. I'm using this rule. Is that this guy? Referring to rule number 1. Can you see? Because if you have less than, when you're working with negative figures, I told you, you can convert negative to positive simply by changing the inequality and changing the sign. Okay, so you can do that. Okay, and then minus over here also probability is that less than minus 2.8. Again, using the rule number 2 now. Is that less than, you can, this becomes, is that bigger than plus 2.8. Can you guys see what I just did here? So this is an important step. Let me rewrite it in a different color. So this is probability. I'll write again. I'm changing the negative z to positive. Is that the less than becomes greater than, minus 1.6 becomes 1.6. So using rule number 1. The other guy, I'm using rule number 2. Probability is that less than becomes greater than, minus becomes plus. Okay, guys? So now you can find the area. Is it greater than 1.6? Right? Is it greater than? Now you know this table doesn't give you greater than. Is it greater than? It means 1 minus. Is it less than 1.6? Right? Because the table doesn't give you the greater than values. Okay, so if you want to find greater than values are found by 1 minus probability is it less than 1.6. Are you with me? This is this first guy. This is the first guy and I'm subtracting it with the second guy. Is it greater than 2.8? How do you get the area? Is it greater than 2.8? Is it greater than 2.8? It's 1 minus probability. Is it less than 2.8? I think this is a little bit longer, right? Compared with what I did before. I think this method was, the first method was very straightforward. Okay, but here I'm using these rules. Okay, I'm basically using rules. I'm not even drawing a diagram. Okay, I'm using the rules that I know to actually get the area. So you can use these rules and you don't even then need a diagram, but it's entirely up to you. So now you can use the values, shall we? So we have here 1 minus, is that less than 1.6? Where is 1.6? That's 0.9452. 1 minus 0.9452. You subtract it. What's the second bracket? 1 minus, is that less than 2.8? 2.8. Is that less than minus 2.8? Where's the answer, guys? 2.8 is here, right? 0.9974. 1 minus 0.9974. I hope you guys can see. Okay. What I did here is I am substituting values to this equation. Can you see? This is the one. Probability z less than 2.6 is what I wrote here. This is the minus sign. Okay. In the middle, this minus sign is what I have here. And again, the one, this one here. Okay. You guys can see what I'm doing, right? This one here is what came here. And z less than 2.8 is what came here. Okay. So this, I just substitute values to this expression. Okay. Can you guys see? I hope you guys can see. It's just a matter of I ran out of space, right? Shall I rewrite it? Let me erase this. Z greater than 1.6, probability Z greater than 2.8. Z greater than 1.6 is 1 minus probability Z less than 1.6. Minus probability Z greater than 2.8 is 1 minus probability Z less than 2.8. If this is difficult, you can always go with the first method. 1 minus probability Z less than 1.6 was 0.9452. Minus 1 minus probability Z less than 2.8 is 0.9974. Okay, I just rewrote the thing here. Okay, from this step onwards, I just rewrote the whole thing. And now you can type it in the cal. What do you get the answer? Okay, guys. So if you when you type it in the cal, you should get 0.0522. Okay, so I think you can see method 2 is way longer than method 1. I agree. Okay, method 1 is easier, but method 2 is going to be useful when we go to the next exercise. Okay, so I think you guys can see I just used these rules. I didn't do anything new, or I didn't do anything, I mean, there's nothing new here. Okay, I'm just using the rules, the three rules I gave you. And the main rule is that greater than is always equal to 1 minus is that less than. So that is our main rule, right? So I'm using the combination of all these rules. So I really want you guys to get used to that as well, because in the next exercise we will need a lot of that. Okay. All right. So now let's go to the next one. All right, so let's try question number 2 as well. So we'll move a little bit fast now. I think you guys can manage this, right? So is that less than 2.12? So I think that's easy, right? Uh, so probability is it less than 2.12? I think is it sorry, this is z less than, right? So if it is z less than, then it's directly the phi value. This is directly phi 2.12, right? I'm not going to draw the graphs now because I think it's pretty obvious. So 2.12, where do we have 2.12? Yeah, this guy 2.12. Can you see 0.9830? Right? You guys can see where the curve is moving. 2.12 is 0.9830. So let's get that. So this answer here is 0.9830. That's the answer for question number 2, part A. Okay. Part B, probability Z less than 1.36. So Z less than 1.36 is gonna be again, you guys can see that it is a less than. So because it's less than, you really don't have any work. You can directly get the answer, right? Because it's less than. So directly go to the table and go for 1.36. So 1.36 moving down. Okay, 1.36 you can see here it's 0.9131, right? So the answer is 0.9131. So part C, probability Z greater than 0.84. Okay, guys. So you know it's a positive value. First thing is it's a positive Z value. Okay, so all you have to do is, the table doesn't give you greater than probabilities, it gives you less than. So all you have to do is just convert. It's 1 minus probability Z is less than 0.84. Okay, greater than you convert 1 minus and immediately it becomes less than. Okay, if you want the equal mark, you can have it here or you cannot have it, that's fine. And then get the answer. So now you go to the table and go to the Z value 0.84. 0.84. So moving down 0.84. Yeah, here 0.84. Can you see? 0.84 is 0.7995. Can you guys see? This is the Z value for 0.84, 0.7995. This is 1 minus 0.7995. And how much is it? 1 minus 0.7995 is 0.2005. Right, guys? All right. Part D. Probability Z is less than minus 0.38. Okay, so now you know how to work with the less than. I mean, here the problem is you have negative Z values, but your table doesn't have negative Z values. So I gave you the rules to convert negative Z to positive Z. So if that is less than, right? So here the rule is that there is less than negative Z value. Okay, here less than minus Z. All you have to do is to flip the inequality and flip the sign. The plus becomes minus. The minus becomes plus. Okay. That's all. Flip the inequality sign and change the sign, and it immediately gives you the equivalent area. Okay. So here, Z. So here this is Z. The less than becomes greater than. Inequality mark is flipped. Negative 0.38 now becomes positive 0.38. That's it. Okay, that's it. Just flip the sign, and then Z greater than 0.38 is, now the table doesn't give you greater than probability. It only gives you less than. So here you convert this to 1 minus Z is less than 0.38. All right, guys. So 1 minus Z less than 0.38. So you have to go to the table 0.38. Here 0.38 is 0.6480. So get the value 0.6480. Okay, I'm kind of rushing through this because I think you guys, I explained question number 1, right? So question number 2, I believe you can immediately apply the rules. So the answer 1 minus 0.6480 is 0.3520. All right. Okay. And then part E, probability B is between minus 2.30 and between 0. So here, guys, for this one, you can use the techniques I did before. Either you can draw and convert the negative to positive, or you can use the rule and do. I really don't mind which method you do, because as you saw me doing this question number 1 part, if I showed you 2 methods, method 1 was very short, where we drew the diagram and got the answer. Method 2 was slightly longer, right? So you can go with method 1 here if you want, or method 2. It really doesn't matter. I'll just go with the theoretical method. Okay, if you want to go with the drawing method, you can go ahead. So this is going to be what, 0 minus 5 minus 2.30. Right, guys? 0 is the probability that is less than 0. 5 minus 2.30 is the probability that is less than minus 2.3. Right? That's the meaning of the pi symbol, right? The less than probability. Okay, here these two I got from the rule here. I gave you this rule previously, right? So you get these, I wrote this from the rule I gave you previously. So is that less than 0 is not an issue for us. We can find that area from the table very easily. But is that less than is the problem, right? Is that less than is the problem, because not less than is not the problem, the negative value, because we can't work with negative value. So I want, first thing is I want to convert the negative value to positive. How do you convert negative to positive? You write B, flip the inequality, less than becomes greater than, and change the sign. Flip the inequality, change the sign. All right, guys, that's what we do here. And then the probability is Z less than 0 minus, and now you have to get the area greater than. But the table doesn't give you greater than probability. So what do you do? Make sure you put a bracket here, and you write this as 1 minus probability Z is smaller than 2.30. Okay, guys, can you see? Z greater than is equal to 1 minus Z less than. The probability Z less than 0, that's from your table, that's 0.5. Okay. And this is 1 minus Z less than 2.30. Okay, so you guys can see what I'm doing here, right? Z less than 0 is this one. Okay, 0.5. And the other value was now 2.3, right? 2.30. 2.30 is here, 0.9893. You see 2.30 is 0.9893. So it's a matter of typing this in the calc and getting the answer. How much is it? Half minus 1 minus 0.9893. So you have to, it's a matter of typing in the calc. So the answer is 0.4893. All right. And then, so that's part E. Part F. Probability Z is less than minus 1.63. Right. So that's again really easy, right? Because all you have to do is the negative. First thing is you can't work with negative Z values. You convert the negative to positive. How? By flipping the inequality, and negative becomes positive. So and the next thing, the table doesn't give you greater than probabilities. It only gives you less than. So you convert this to 1 minus Z less than 1.63. Because when you do 1 minus, immediately the greater than becomes less than. And then 1.63 value, you get it from the table. 1.63 is here, right? 0.9484. Can you see 1.63, 0.9484? And that answer is going to give you 0.0516. All right. All right, guys, and this guy. So part G, that is between minus 2.16 to minus 0.85. Okay, in this case, both are negative, right? I think if I go to do it in this method, okay, this method, things are gonna get very long, okay, because it's, I think you saw that in the example before. You know what, in this case, let's make our life easier. What do I mean by that? What I mean by that is, I know that I need the area from minus 2.16 to 0.85, right? Both are negative. It's easy because both are negative. If one was negative and one is positive, you can go with the rule. So you can get the exact same area between plus 0.85 and plus 2.16. The exact same area. So we'll go with that. I think that makes our life easier. So here the Z value is between 0.85 and 2.16. So you need to actually be very careful here. Can you see when the signs are changing, the values, the placements are changing. So you have to do it. I mean, draw a diagram and do it properly. Okay. If you are going with diagrams, then use your intuition and do it properly. Okay. Otherwise, this you can do it by using the techniques I did here. Okay. I did one question in question number one. Part F was done in that very long way, right? So you can do that as well. Okay, but I think this is the easiest, right? So this is directly phi 2.16 minus phi 0.85, the less than probabilities directly, right? And you can directly get the answer from the table now. So phi 2.16, 2.16 is 0.9486. Okay, so this is 0.9486 minus 5, 0.85, 0.85. Yeah, 0.85 is 0.8023, right? 0.8023. And then you subtract. Okay, so the answer is 0.1823. All right, so you can do this in the long method as well. Okay, no, a method without diagrams, you can use all the rules I gave and do the question in that manner as well. No problem. Okay. All right, guys. Next one, z between minus 1.57 to plus 1.57. So you can do this in, let me do it in the theory way, or you can draw the diagram and do it. There are many ways. Okay. So this is actually pi 1.57 using the rule. Okay. Minus pi minus 1.57. Okay, phi means the probability z is less than, right? Okay, so is that less than is something that we definitely want to work with, right? Is that less than is the familiar probability for us. So I'm not going to change anything in is that less than because I know I can get this one directly from the table. Is that less than a positive is that figure? A positive figure is what we require because we can get the answer. But here this guy we need to change because it is that less than a negative value. So negative values are not there in the table. So how do you convert negative to positive? Is that the inequality mark flips, negative becomes positive. Right, guys? So you come to this point. After you come to this point, you know, is that greater than values are again not found in the table. The table has is z less than. So how do you convert to z less than? I'm writing the same thing again. This guy I rewrote it here and then minus, use a large bracket. And is that greater than 1.57 is 1 minus the probability. Is that less than 1.57? Okay, that's it. And now let's get the answer. So is it less than 1.57? Let's go to the table. 1.57. Yeah. So 1.57, you can see here 0.9418. Okay, 0.9418. 0.9418 minus 1 minus 0.9418 because it's the same guy, right? Okay, so it's a matter of typing the values in the cal and then you get the answer 0.8836. Okay. All right, guys. Okay, so I think we have discussed everything here. Okay, so question number one I discussed with the graphs and with the practical, I mean the theoretical methods. And now question two I did mainly using the theory methods. Okay, so any method is fine as long as you can get the answer. Okay.